Well, I'm going to address the issue of enterprise architecture for a moment, but I will give you the theoretical explanation for why you can negotiate with a terrorist but not with a methodologist. For 7,000 years, we were manufacturing chemicals. There were chemists manufacturing. Actually, they weren't chemists, they were alchemists. And the way they learned how to manufacture chemicals is they did it by trial and error. And you just try it out. If it works, you write it down. That's a best practice. If it doesn't work, you don't write it down. It's not a best practice, but they learn by trial and error, which takes a long time to develop that. It takes a lifetime to develop a chemical. In fact, they were really creative people, by the way. They figured out how to build gunpowder, by the way. That's pretty good, you know. But it takes a lifetime. So if you challenge the methodology that it took them a lifetime to create, it's an attack on their identity. I had learned this the hard way, by the way, because when I would observe things from my methodologist friends and say, that's not the best way to do this, you need to do it this other way, it was an attack on their identities. That's why you can negotiate with a terrorist, but you can't negotiate with a methodologist, basically. Anyway, that's the theoretical explanation for why it happens. The other thing, I figured out, we were in Copenhagen, a couple days ago. I figured out why Ron and Roger put me last on this last presentation, because I'm the one who is standing between you and lunch. Okay, so the pressure is on me, and they were afraid that, they were afraid that I was going to lapse into my tutorial material. I had 3 or 4 days of material, okay, so they didn't want me to lapse into a tutorial, but I will give you some overview here from an architecture standpoint. The question, the challenge is, I kind of raised this issue before, the challenge is, what is your strategy, Chief? What is your strategy, Chief? This is not actually a technical question, this is not a technology issue. The question is, what's your strategy, Chief, for addressing orders of magnitude increases in complexity and orders of magnitude increases in the rate of change? Do you think this is not happening? This is happening. The question is, what are you, Chief, going to do about this? And 7,000 years of history, by the way, would suggest that the only known strategy for addressing complexity and change is architecture. Now, in terms of architecture, if whatever it is that you're going to try to create gets so complex that you can't remember how it works at the level of definition is required to create it, you have to write it down. Which is basically architecture. And oh, by the way, if you ever want to change what you create, you have to retain the descriptive representations to identify and avoid unintended consequences of changes. That is architecture. If there's any question in your mind, go down to the city hall, talk to the building department, and find out what they will allow you to change or get a permit to change your house, and you'll be shocked at how minor the changes are. If you want to change where you're hanging a picture, for example, the theory is fundamentally you have to get a permit. Okay, why? Because you have to understand what the unintended consequences are. You change where the stress is and where the weight things are, and your house falls down. They don't want the government, as soon as citizens start getting hurt, the government will be in there with both feet with regulatory requirements. They won't let you change it unless you understand what the unintended consequences are. In any case, the key to accommodating complexity and change is one thing: architecture. Basically, so and I would observe it as not optional. In terms of complexity, the way that humanity has learned to deal with complexity, fundamentally what you have to do is you have to reduce the sample size through classification. But there are different ways to classify things. You can classify things in a single dimension, which would be a hierarchy, a decomposition. This is heavily used in manufacturing because the farther you decompose things, the smaller the pieces become, and the cheaper and faster it is to create them. been heavily used in the IT domain. We're very manufacturing dominant, so typically the way we approach everything is through decomposition. In fact, it lends itself to analysis, problem analysis. You're looking at a smaller piece, and you can implement it faster and cheaper. We see this in the software domain right now. If you only have to define a few more lines of code, the fewer lines of code you have to define, the cheaper it is to create it and to get it to work. So a single variable or single dimension of classification is really helpful for manufacturing. It lends itself to manufacturing. However, probably everybody in this room will recognize this. If all you do is decompose things, you'll have the same content starting to show up in more than one node at the bottom of the tree. Okay, that's really inhibits change, basically. So you can change things one place. If you don't change it every place that it recurs, now you have a discontinuity. You'll have to compensate for that, which is basically entropy, in effect. So the other thing is you can change something in one node that will have minimal unintended consequences, but if you change the same thing in a different node, it might have maximum unintended consequences. So if a one-dimensional decomposition, what happens is that you end up with the same content in more than one node at the bottom of the tree, which basically inhibits change. That's basically the problem we have right now with the application portfolio that we have. In any case, you could use a different way to classify things, a multi-dimensional classification, in which case you're going to have more than one dimensional classification. This will show up as a matrix, typically. You have one classification on one axis, a different classification on a different axis. So the intersection between the two classifications ends up with with an intersection, or it's common to both classifications. Now, this is really helpful because what you can do, you're putting one kind of thing in any one category. You're going to have one kind of thing in one category. So now you can normalize it. You can identify where there's a discontinuity, where the same thing shows up more than one time. In fact, set theory now works. Okay, so in fact, those of us who come from the IT domain, we didn't even have normalization in our vocabulary until Ted Codd came up with a relational model. The two-dimensional classification. Now you can normalize things. You can identify where the discontinuities are, and you can get rid of the replication and duplication. It was basically mathematically where that was coming from. This lends itself to engineering. Okay, multi-dimensional classification. By the way, you could have more than two dimensions. You could have a third dimension, or fourth, or fifth, or sixth. You can graphically depict the three dimensions into a cube. Or if it's more than that, you'd have to have an automated way to do it. But a multi-dimensional classification is really helpful for doing engineering because you can normalize things, get rid of discontinuity, the potential inconsistencies. But the problem fundamentally is this requires analytical precision. Actual work is required here, and it's engineering work. Now, I'm giving you an infusion of honesty. I used to have a presentation I made where I'd say an infusion of honesty. You know, we weren't being honest with ourselves, by the way. But there's nothing magic going on here. If you want to engineer something, you are going to have a multidimensional classification to deal with complexity, fundamentally. Now, having said that, this is a two-dimensional classification. You know, here's one dimension. The classification on this dimension is the primitive interrogatives. What, how, where, who, when, and why. That goes back for 7,000 years to the linguists. If you want a complete description of something, anything, whatever it happened to be, you have to answer 6 questions. If you don't answer all 6 questions, that doesn't mean that they're not relevant. It means that you didn't formalize the answers, which means you're allowing anybody and everybody to make whatever assumptions they want to make about the answers to those questions that you don't formalize. So you don't have to formalize them all, but you're allowing anybody and everybody to make assumptions. You heard Ron make an observation about this. If you don't have consistent definitions of whatever it is, concepts, you're making a point about concepts. You're not talking to each other. You're not communicating. I mean, you could be talking to each other, but you're not communicating, basically. In any case, that's one dimension of the classification. The other dimension And the other dimension is reification. This comes out of philosophy. Aristotle and Plato and those guys knew that an idea that you might have is one thing, but the realization of that idea is a completely different thing. And if you want the realization of the idea to bear any resemblance with what the idea is, that idea has to go through a well-known set of transformations. And let me say that again. A well-known set of transformations, not decompositions. It's transformation. You have to identify it, you have to define it, name it, so at the boundaries of the discussion, you're going to limit the discussion of whatever the domain is. You have to define it, now you have the semantic structures, what the meaning of things are. Then you represent it. All the engineering design is done with representation, not with physical material. Then you specify it based upon the technology available for implementation. Then you configure it based upon the tooling, whether it's manual or automated tooling. Then you instantiate it. If it goes through that set of transformations, then the end result, the realization, will bear some resemblance with what the idea was at the outset. This is just a two-dimensional classification. By the way, if you go back to the observation I was making about chemists, until Mendeleev published the periodic table, there was no order. Nothing was repeatable and nothing was predictable. If you do not have an ontological structure, nothing is repeatable and nothing is reusable in effect. In any case, this is a two-dimensional complexity. This is very similar to what Mendeleev, this periodic table. Periodic table, it classifies all the elements in the universe by the number of neutrons and protons in the nucleus by the number of electron rings. Another, by the way, it was only about 50 years after Mendeleev posed the periodic table that the physicists were excluding atoms. They didn't even know they existed up until that time, by the way. But as soon as you have an ontological structure, friction goes to zero. It gets really sophisticated really quickly. Let's make an observation here. But in any case, this is just a two-dimensional classification for dealing with complexity. I'm rushing. I'm talking so fast I'm getting out of breath myself. I'm really trying here. I got 8 more minutes to go. So, in any case, this would constitute. This is all the interrogatives are orthogonal. They vary independently from one another. They're all orthogonal. These are all unique, and these are transformations. These are all unique as well. So this is an ordered structure for accumulating normalized increments of business knowledge, iteratively and incrementally. I would say little by little, issue by issue, CEO's problem by CEO's problem, from here to eternity, just from now until forever. This is the key to the knowledge age. You want to retain the knowledge. Fundamentally, you have to have an ontological structure. And by the way, I would observe this ontological structure is defined quite independent from the domain of interest. This has nothing to do with enterprises or systems or technology or airplanes or buildings or locomotives or battleships or X, Y, Z. It's completely independent. And the classification has been used by humanity for thousands of years on both dimensions, both axes. This is a significant issue because I did not invent this. All I saw was the pattern, and I saw the pattern in the older disciplines of engineering and manufacturing and architecture and construction. Basically, the terminology, interestingly enough, is pretty similar in both those older dimensions. The logic structure is identical. The terminology is a little bit different. In any case, that's where I learned it. And all I did was I put enterprise names on the same intersections between the two classifications. That's all I did. I did not invent it. It's all just the Zachman framework. But I appreciate that, but I did not invent it. Okay? I appreciate that, that they would attribute it to me. But all I did is I saw the pattern, and then I populated it with a vocabulary that was relevant to the enterprise, in effect. Now, this is the basis for the business knowledge base. And I would assert the business knowledge base, that's what you need in order for engineering and manufacturing enterprises. This is architecture for enterprises. And if you really want business agility, you are going to have the structure. If you don't have this, I will tell you, you do not have business agility. This is what you need to do engineering of enterprises, basically. But this is really simple. We'll go back to the first grade. The alligators go in one box, the fire engines go in a different box, the people go in another box, and so on and so on and so on. All you're doing is putting the same type of thing in every different category. This is organizing your knowledge base for engineering design. Ron basically, in his quote, he basically observed, the knowledge base is complicated. Enterprises are complicated. We're dealing with the most complex object humanity has ever conceived of so far, an enterprise. And that enterprise doesn't have to be very big to get really complicated. It gets really complicated really quick. So we're talking about extreme complexity here. There's nothing simple, nothing magic going on. There are no silver bullets. That was the Fred Brooks article. Really interesting article, by the way. But in any case, up here, the scoping list, the context, the identification, here's the definition, here's the business concepts. That's what typically when Ron talks about the enterprise, these are the business concepts for management purposes. These are the system logic, these are the system models, in effect. That's what you're thinking about the enterprise. Here is more the reality. Now we're employing the technology, physics, the technical constraints. Here's the tooling configuration, and then here's the enterprise instantiation. Now we're approximating the reality. As a matter of fact, in Ron's 3 levels, you have the context. Here's the management perceptions. Here is the operational, systematic way that those concepts will be implemented. Here is the technology manifestation, the technology constraints. So fundamentally, the mapping to Ron's 3 levels of definition, that's the way it goes. Here is where, these are the ideas, this is where you're doing engineering. This is where, you have the definite, here's the semantic structures, what management is thinking about. Here is how the system logic, how logically we're going to process records and keep track of the data, if you will, and the transactions that realize whatever the concepts are here. And then here is where the reality, they have to employ the technology constraints and the tooling, the vendor tooling, whether they're manual or automated, and then the enterprise instantiation. You recognize why I was so excited about Ron's definition. If you do not define the concepts, you can't expect the customer, where the customer is touching the enterprise down here, or the implementers, the software people are making assumptions about what you're thinking up here. It's not going to work. There's no way you're going to end up with an instantiation that has anything to do with what the owners are thinking about up here. So I was really excited about, Ron's definition. I mentioned that when I was going through the material. But anything, once again, nothing is magic. I have a friend, my friend, the Indian friend, who says, this is reification. Here's the identification, definition, representation, specification, configuration, and so on. Reification is incontrovertible. You can argue with me all you want to, say, but that takes too long, it costs too much. Well, I will tell you, if you want this to have anything to do with that, you're going to go through that somehow or other. And I never said you had to do it all. I said you had to do it little by little by little over some long period of time. So that you accumulate the knowledge base over time, from now until some time, eternity. This is a different way of life. It's not just, it's not a project. It is, Roger uses a different word, but
it's not a fat diet.
Oh, yeah.
It's a lifestyle change.
It's a lifestyle change. This is enterprise architecture. Okay, some of you guys have heard me say that before. Newt's a good friend. He's been with me a number of times when I've said, this is enterprise architecture. If you want to do enterprise architecture, you are going to produce these, what I would call single variable, ontologically defined descriptive representations. If you are not producing these single variable, you know, here the definition is 2 dimensions of the classification, single variable, only one thing goes in every one of the cells. If you are not producing that, you're not doing enterprise architecture. Now, you may be doing something really good. I would never tell you to stop doing it, particularly if you're having any success. But if you want flexibility, integration, interoperability, reusability, alignment, if you want those kind of characteristics, these single variable representations are going to be there someplace. And if you cannot show those to me, I know you're not doing enterprise architecture. So forgive me for preaching at you guys. But, I mean, money of you have probably heard me say that before. So the road ahead for agility between now and someday, my observation is, you got to begin to populate these, accumulate the knowledge base, single variables by single variable, and so on, from now until whenever. Now, I make this observation, it's just an observation. If the enterprise has no enterprise architecture, and if the enterprise architecture components, the single variable, do not exactly equal the enterprise at every given moment. You understand what I'm saying? Real time. And I will tell you, the way we transcribe knowledge today is not real time. If you factor out the single variables, now you can make it real time. But now we have complex documents that are filled with all kinds of stuff. You know, Ron, you know, and I.B. Watson, with all due respect to I.B. Watson, isn't going to magically sort that out. Ron proved that to you unequivocally. In any case, those variables, those single variables, have to be real time. And if any fact reoccurs anywhere in the enterprise, unsynchronized, you have the same thing in there more than one time, then I humbly submit the strong possibility exists that nobody actually knows how the enterprise works. Problems can't be diagnosed and multiple solutions posed or simulated before making investments. General management will not be able to change the enterprise in time to accommodate the external rate of change, and the cost of operations is likely escalating. Guys, make that observation. In any case, we appreciate you guys holding still for a few hours today to think about this. I think this has far more implications than just simply enterprises and systems and technology or management or whatever. I think this has to do with the destination of humanity. Because we're talking about the information revolution, the knowledge revolution to the next wave. And if we can't accommodate this, which is a different paradigm, whoever can accommodate it is not going to make it into the next wave. Okay, I think this has far more implications. Once again, I come from the domain of enterprise architecture. I spent a few years there, and Ron is from the data business rule domain, and Roger from business process value domain, which are completely different domains. And the whole thing has to do with complexity change. Interestingly enough, we have been together, you know, we don't collaborate on a day-to-day basis, but we've known each other for decades, and really, you know, somewhat intuitively understood that we're basically focused around the same thing, which has to do with the business. Okay, and it is, go back to the Drucker observations. In the information revolution, he talked about the information revolution. It is not a technology issue. It is the owner of the content that is the beneficiary of the next revolution. So we really appreciate you guys taking some time out today to think through these things. I think it has far more implications than any of us have any understanding, including myself. But I think that this is the right path. In any case, I appreciate you guys being here. We all appreciate it. We've talked about being here with you guys and appreciate it immensely. And Patrick, you're on.